All right. Good evening, everyone. It's so great to know you are all out there. I can see the number of participants, and that's fantastic. Yes, please definitely fill out the poll so we know how many people have come tonight. That is really amazing. As we do this program, if you think of a question, please go ahead and put it in the Q&A. I'll get to the programs at the end, but you don't have to wait to the end to ask your question. So just so you don't have to forget in the middle or at the end of the program what you were thinking, maybe near the middle. So definitely put those in and I'll be happy to answer your questions at the end. Um, so yeah, we're going to talk all about the solar eclipse coming up. If you remember all the craziness from 2017, we get to do it all over again. But I'm here to tell you when to look, what to expect, how to safely view the solar eclipse. And we're going to start with talking about why we even get solar eclipses in the first place. Uh, the amazing thing about solar eclipses or any eclipses is they really don't happen all that often. And so when we say, you may read a news story or something and that refers to such and such a phenomenon as rare. This one kind of actually is. So on average, we get a couple solar eclipses a year, but that does not mean everybody gets to see them. It means only a specific chunk of the earth gets to see them, and you may not get to see any of them in a particular year. So why are they relatively rare? Well, let's find out. All right, so I've got an animation. So I haven't started it yet. What I want to explain real quick is what this animation is showing you. So that little tiny circle in the middle, the little small one, that is the Earth. And the even tinier dot to the lower left, that's the moon. These are to scale. So if you're watching this on your phone and you're finding that that is almost impossible to see, that's okay. You can go back and watch the recording afterwards. But the moon is relatively far from the Earth. It's about 30 Earth diameters away, about 240,000 miles, give or take. And so what happens is when you're looking at this group from the top down, so imagine you're looking from the Earth's North Pole. You're high above the Earth's North Pole, looking down, and you got the sun shining on the moon, and the moon casts its shadow into space. You've got the sun shining on the Earth, and the Earth casts its shadow into space. So let me start the animation. So as the moon goes around the Earth, you would think that maybe every time the moon got in between the Earth and the sun, we should get a solar eclipse, right? So what's happening with a solar eclipse is sun shines on the moon, moon casts its shadow into space. If the shadow happens to fall on the Earth and you're underneath that shadow at just the right time, you get to see a solar eclipse. Well, the moon goes around the Earth about every 29 and a half days. Okay, well, why don't we get solar eclipses every single time the moon comes around? This is at the phase called new moon. All right, so why is there not one at every new moon? Well, let's keep the animation going. And we're going to now take a look from the side. So this is a side view. So you may start to notice that the moon's orbit around the Earth is not flat. At least it's not flat compared to the Earth. It's tilted. So tilted at about 5 degrees. So when the moon gets in between the Earth and the sun, it's not in the right spot for the shadow to fall on the Earth. The shadow either goes below the Earth or above the Earth. Well, this tilt stays at 5 degrees, but where the tilt points wobbles. And it takes about 18 years for that wobble to wobble once. So let me get that going. So it's going to show you what one of these wobbles looks like. So that might be a little bit hard to see. But when the main point is when everything lines up just right, when that wobble lines up just right so that the moon's shadow falls on the Earth, you get a solar eclipse. On average, a couple times a year. But again, not every place on Earth is going to see it. And if you saw one of them during the year, you might not see the other one. You might not see either of them. So it is truly a relatively rare event. And it doesn't last very long. The shadow passes over the Earth. And once the shadow exits the Earth, the eclipse is over. All right. So I've got another perspective here. So we're going to take a look at the moon's shadow as it passes over the Earth. Now, this animation was done for the 2017 eclipse, so this orientation of the shadow is not quite right for this next eclipse, but I just want you to get the idea. We've got the moon's shadow. Now, I want you to notice one important thing. Did you notice a couple different colors to that shadow? There's two different parts to the moon's shadow. There's two different parts to the Earth's shadow. There's a darker inner shadow and a lighter outer shadow. All right. So as this darker inner shadow spot goes across the face of the Earth, if you're inside that dark inner shadow spot, that's where you get to see the moon 100% cover the sun. If you're outside that shadow spot, but still within that lighter inner shadow, that's when you would see the moon partly cover the sun. You don't get to see what we call the total solar eclipse. You get to see a partial solar eclipse. The closer you are to that shadow spot region, the more of the sun is covered by the moon. The farther you are from that shadow spot region, the less of the sun is covered by the moon. Until if you're completely outside that shadow, you don't see the solar eclipse. All right. So if you take a look, that's delineated by the yellow circle here. So if you take a look at the 2017 eclipse, there were folks in South America who did not see the solar eclipse at all because they were fully outside the moon's shadow. Right? The moon's shadow wasn't large enough to cover the whole Earth. So that little shadow region, the size of that does vary. By the way, this is to scale too. Pretty crazy. You don't think of the moon really being that far away. It seems like it's right next door. But yeah, it's fairly far. But the size of that darkest inner shadow does change. It depends on if the moon is a little closer or farther from the Earth. For this next eclipse on April 8th, that shadow region is going to be somewhere around 130 miles wide. For the 2017 eclipse, it was about 78 miles wide. So what does that mean? It means for those of you who get to go see totality for April 8th, it's going to last a little bit longer. The shadow spot is bigger. It's going to take a little bit longer for that shadow to pass over you. So that darkest inner shadow where you get to see totality, that time period can change, or it's different from one eclipse to the next. So this next one, we get totality for up to a little over 4 minutes in length, which sounds like a lot, but it's really not. For the last eclipse, it was a little over 2 minutes. The most you can have for totality is about 7.5 minutes. This is not one of those eclipses. We don't get to see a 7.5 minute one for a while. Actually, in this area, it's going to be a long while before we get to see one of those. All right. So let's do the animation for the next eclipse. Let's see what that shadow is looking like. So as the shadow is passing over the curved Earth, it encounters the Pacific Ocean first. And that red dot that you see in the middle, that is where the darkest inner shadow region is. That's it. That's about 130 miles wide, a little bit less than 130 miles wide. The shadow is going to come up from the southwest across the US and up toward the northeast. Let me do this again. So again, the shadow region comes over the Earth. We have to wait for it to get to us. So there will be areas to the southwest. The eclipse will start earlier for them because it'll encounter them first. It'll sweep over us, and then it will go off the edge of the Earth on the other side. And the shadow travels from west to east because the moon is traveling in that direction around the Earth. All right, so the shadow is going to move because the moon is moving around the Earth, which is remarkable to think about. All right. Okay. There is something interesting. If you line up the sun, the moon, the Earth to create a solar eclipse, if everything lines up just right, that means either the full moon after the eclipse or the full moon before the solar eclipse. You got everything lined up for a lunar eclipse. So if you get a solar eclipse, you can get an associated lunar eclipse. For this next eclipse, solar eclipse, we do have a lunar eclipse, but I'm here to tell you, don't get too excited. I'll explain why. All right. First, by the way, this is wildly not to scale. So after you've seen my 2 to scale animations, you see this one and you go, oh, wildly not to scale. Anyway, sun shines on the Earth. Earth casts its shadow into space. The Earth's shadow has a darker inner region and a lighter outer region. As the moon passes into the Earth's shadow, it encounters the lighter outer region first. We call that outer region the penumbra. That word penumbra, the main part of the word umbra, comes from the same root word where you get the word umbrella. It means to block from view. All right. So the moon goes into that lighter outer shadow, and then, whoops, sorry about that. Let's start that over. So goes into the lighter outer shadow. If it happens to go into the darker inner shadow, like we see here, if it only goes partly into the darker inner shadow, we call that a partial lunar eclipse. If it goes completely into the dark shadow, we call that a total lunar eclipse. You know, when the moon appears to turn red or gray or kind of a brick red color. We had a couple of those eclipses, a couple of Novembers recently. So November 2021 and November 2022, we had a couple of those total lunar eclipses. And remarkably, for November in Chicago, it was clear. Don't ask me how we got that 2 years in a row, but we took it. It was good. So that's that. All right. So what happens though if the moon only passes into the lighter outer shadow? We call that a penumbral lunar eclipse. Unfortunately, that's the lunar eclipse that's coming up. So it's going to start the evening of March 24th and it will go into the morning of March 25th. And the moon at maximum will encounter most of the lighter outer shadow. Even a little bit of the moon itself won't be within the shadow at all. So that part will remain basically the regular whitish grayish color that you normally see. When it goes into that lighter outer shadow, well, what could that look like? Well, I'm here to tell you, you can sleep in for this one if you want to, because this is about what it looks like. So 11:53 p.m. March 24th into 4:32 a.m. March 25th. So those are the bookend times of the eclipse, with the peak of when the moon is at its maximum in that lighter outer shadow. It's a little bit after 2 in the morning, about 2:12 in the morning, Central Time. But take a look, the picture on the right. You see it? Does that look impressive? Is that really amazing gray or red or anything color? No, it's really not. So if you didn't know the eclipse was happening, you might have a tough time even noticing. The amount of color change is just that insignificant. If you want to stay up for this one, you can. If you happen to be up to see it, great. Look out the window at it. If you want to sleep in, you won't hurt my feelings by doing that. But also know that it's kind of cool that we get the lunar eclipse for the next solar eclipse, because not everybody, if you get to see the solar, do you actually also get to see the lunar. So it's kind of neat that we get to see both. There is a partial lunar eclipse in September of this year, September 17th. We don't get to see the solar eclipse associated with that one. There's also a total lunar eclipse March of 2025. We don't get to see the solar eclipse with that one either. So, yeah, this one, not very impressive, but it is neat that now you know why we get the lunar eclipse then followed by the solar eclipse. It's because everything all lines up. But I wanted to mention it because I would not be surprised if you start seeing kind of clickbaity news articles saying lunar eclipse coming up, it's going to be great, you can't miss it, it's rare, blah blah blah. No. If you want to know, will the astronomer be sleeping in? And the answer is yes. More than likely, I will not be up for this one. So I hope it's clear skies for everybody who wants to get to see it. And I see the little laughing emoji going on the screen, so I'm glad that you got a kick out of that one too. Okay, so the solar eclipse. I hope there are some of you who are going to be traveling to go see totality. If you are going to totality, put it in the chat. If you're traveling somewhere, just let me know where approximately the state. You don't have to tell me exactly where you're going, but if you're going to totality, throw that in the chat. I'd love to know if you're going. Um, anyway, if you're going to travel to see totality, this is what you really want to see. This is a picture of a total solar eclipse. This is what happens when the moon 100% covers the sun. All right. And I'm seeing some chats come up. Oh, that's great. It means I'm not reading them yet, but I know that some of you must be traveling. That's fabulous. All right, we'll get to that when we're done. So the moon's going to completely cover the sun for a short period of time, at most a little over 4 minutes in length. It might be a little bit less than that, depending on where you're going. But what makes these so special is how rare they really are. The same spot on Earth gets to see totality on average about every 375 years. Now, that is not like clockwork. Southern Illinois is getting to see totality after 6.5 years. So that 375, again, just an average. So what is going on is the moon is passing over the sun, lining up just right so that darkest shadow spot, it passes over you, and you get to see a part of the sun that you normally don't get to see. And that's called the corona. Now, the corona is that whitish feature that you see around the moon and sun combo in this picture. And that is the sun's outer atmosphere. We started calling it corona about 200 years ago, a little over 200 years ago. And it's the sun's outer atmosphere. They didn't know what it was exactly a few hundred years ago, but they could tell it was part of the sun. And it was given a name that tells you what it looks like. Corona is the Latin word for crown. And so it looks like a crown around the sun. So they named it based on what it looks like, not what it does or what it is. But it's the sun's very hot outer atmosphere. And you only see it during totality because you have to block the brightest part of the sun that we call the photosphere. So if we if we get to see the sun anytime soon, that bright part of the sun, that's where the light comes from that we see, and that is the photosphere. You need to block that photosphere. By the way, photo means light. Sphere means region. It's the region of the sun where the light comes from. But you need to block that because even 1% of sun is too much to see the corona. So this is something that you have to go to totality to be able to see it or watch it online, right? What you also get to see when you're encountering the moon's shadow is the sky above you is relatively dark, not totally dark. It is not pitch black. That's because the corona is about as bright as the full moon. So it's safe to look at. You actually don't want to use solar glasses or solar viewers. So I've got both of them here. Oops, upside down. You don't want to use those when looking at totality because you won't have enough light passing through these safe solar glasses in order to see it. So you have to take your solar glasses off to be able to see it. But it is safe to look at. There's nothing wrong with looking at totality itself. As long as all the photosphere is blocked by the moon, it is safe to look at. Now, I mentioned the sky above you is not totally dark. You might see a few objects in the sky. I will tell you, for those of you who are going to totality, I'll show you what else will be in the sky at that time. And I'll also give you a little tip on how to see that stuff even a tiny bit better. So we'll get to that in a little bit. You might also see that the horizon off to the distance is lit up a little bit brighter. And that kind of is given the colloquial phrase, the 360-degree sunset. It's because the shadow of the moon is above you at that point. It's over you. And you're looking out toward the region outside that moon shadow off in the distance. So those of you who are going to totality, definitely take a look up in the sky. Just take a quick look off into the distance and see what that looks like as well. I'll give you a few other things that you can look for too as we go on. There have been a handful of folks who have been able to see what this shadow looks like from space, and those are the astronauts on the International Space Station. And so they snapped this picture, and that shows you the moon shadow over the Earth, that darker inner core. That's where you want to be. Out here, Actually, there's two reasons why you might not have wanted to have been out here. Number one, it was outside the darkest shadow. Number two, it looks like it was cloudy in this particular location. Clouds absolutely can affect what you see. Even if you're under totality, if it's cloudy, you're not going to see totality itself, but the sky will go dark. But again, not as dark as a pitch black night. It's not that dark. But it is still enough that occasionally you have the town that has the light sensors that if they didn't turn them off for totality, you might see the street lights come on during totality. That has happened in places. All right, I'm going to tell you what to expect in our area. And then I'll show you what to expect in the totality area, because it looks like we've got audience members going who are going to be in both areas. So April 8th, 2024. The timing that I'm showing you on these slides is good for the Chicago area. If you're traveling to the path of totality, if you're traveling to some area outside the Chicago area, I'm going to have to show you where to go to look up the exact timing for where you're going. It's going to depend on where you're going. It's going to depend on what time zone you're in. So you don't want to use these times for every place in the US that's going to see this eclipse. You want to use these for the Chicago area. So 12:51 p.m. is when the eclipse starts, approximately. It'll be within a minute or so. And you're going to start to see the moon just start to peek over the edge of the sun. It'll take a little bit before you actually notice it, but you'll start to see it. The moon will slowly start to creep across the face of the sun. And I'll give you some stuff to look at this point as well in just a bit. But at its maximum, so in our area, 2:07 p.m., give or take, we're going to have the sun covered to the extent of approximately 93 to 94% in the Elgin area. I'm in Aurora, so here it'll be about 94%, and a little bit farther south. We got an email from a teacher in Wilmington. Wilmington, the sun will be covered at about 95%. So the coverage will depend on where you are, but about 94% for our area is what this will look like. Now, will you need safe solar viewers or solar glasses in order to see this? And the answer is absolutely. You absolutely will. At no point for any of us in the Chicago area or anywhere outside the path of totality will you be able to ever look at the sun without the safe solar glasses or the solar viewers. This much sun, 4%, 5%, that is way too much sun to look at directly with your eyes. 1% of sun is too much to look at with just your eyes. You do not want to do that. So you definitely want to keep your eyes safe and use the proper solar glasses for those, right? The moon will continue to slide across the face of the sun, and then the eclipse will be over at 3:22 p.m. All right. Again, within a few seconds, tens of seconds, maybe a minute, depending on where you are. Okay. So, what are some things you can look for? Well, no matter where you are, as long as the sun is covered at about 50% or more, what I'd like you to do is look down at your shadow. Look down at the shadows of other things around you. So you want to look around, and as more and more of the sun is covered, please notice your shadow is getting sharper and sharper. Normally, our shadows are very fuzzy. I'm not sure if you've ever noticed. Next time we actually get a sunny day, whenever that is, maybe sometime next week, I'd like you to go outside, look at the edges of your shadow. We draw shadow edges in kids' drawings very precisely, but they're really not. The sun is an extended object, and so that extended light source creates fuzzy edged shadows. As you cut down on the amount of light from the sun, you actually block most of the sun from view. The edges of those shadows get sharper because you've got less of an extended light source, right? So definitely look down and notice that. Take a few pictures. Take a picture before the eclipse starts, or maybe a little ways into it, and then take a picture maybe most of the way to the sun being covered in your area, and notice how different those things look. those of you going to totality, here is what you're going to be able to look for. Okay. So about 4 seconds prior to totality, and I will show you where you can go get the exact timing for the eclipse for wherever you're going. I'll show you the resource when I'm done to be able to show you this, because you want to get ready for it ideally to the second if you can. So about 4 seconds prior to totality, the moon is going to cover the sun almost completely until the last few bits of rays of light from the sun are just shining through some valleys that are on the edge of the moon. And you can actually see this if you do it maybe 2, 3 seconds prior to totality. You can briefly glance up. You can actually see that. It's okay because you're only looking for a handful of seconds, and you'll see this. This is called Bailey's beads. And if you're worried about this, about looking too soon, then don't worry about it. You'll see pictures from people. So if you're worried about taking the solar glasses off too soon, but 2, 3 seconds, you should be okay. But notice those individual little pinpoints of light. That is light shining through valleys on the edge of the moon, shining past little mountains and things. Then you get to see totality, which is amazing. And you definitely don't want the solar viewer in front of your face for that. Then when totality ends, again, you want to get the timing to the second if you can. The moon will start to slide away and you'll see one bright and getting brighter spot of light. And you can look for 1/1002, put the solar viewer back on. What you're seeing is the light from the sun shining through one particularly deep valley on the edge of the moon on the other side. And we call this the diamond ring effect. So Bailey's beads is the many little splotches. The diamond ring is this side. And so you'll see that during the eclipse, which is really cool. But look for like 2 seconds and then either turn your head away from the sun or get those solar glasses back over your face. I want to keep everybody safe. Now, I hope this works. Oh, wait, it doesn't. So you know what I'm going to do? I'm going to stop sharing my screen for a second, and I'm going to show you a movie clip. So give me a second. I had a feeling this might happen. So I'm going to stop sharing. Stay with me. And I'm going to go and grab a movie clip that I have on my desktop. And then I'm going to go back to Zoom. And I'm going to share my screen. And there we go. Okay. So this is a sheet. This is a sheet that was on the ground, and these people are looking at, they're looking down at the ground. And this was a little bit before totality. And I'm going to move it forward. I hope this is coming through on your end. I hope you see the ripples on the screen. These are called shadow bands. And as you get just a tiny, tiny crescent of sun, just the tiniest little crescent of sun, you might get to see shadow bands. We saw them for the 2017 eclipse, which is really amazing. Not everybody gets to see them. They don't always happen. But what you're seeing is essentially what's happening. I'm going to stop this for a second. There we go. And I'm going to go back to my PowerPoint. Give me a sec, and then I'll explain what's going on so that you have the full story. Okay. There we go. So what's going on is you've got the sun's light shining through different temperatures of air, different densities of air. And it's just like when you see sunlight shining through water onto the floor of a pool. Have you noticed you've seen those ripples of light on the floor of a pool? Exactly the same thing, except it's sunlight shining through ripples of air. And air is acting like a fluid at that point. So you want to look for this maybe a minute, maybe two prior to totality or just after totality. So put down a big white sheet. Just go get a big white sheet, weight it down with weights at the edges, stretch it out nice and tight. And you can try to get video of this. It might be pretty tough. They aren't going to be incredibly distinct. They may not show up on your camera, but you might see them. So that is an effect that I'd like you to look for. Again, either before totality or after totality. So you want to look for shadow bands first, maybe a minute or two prior, then Bailey's beads, totality, diamond ring, shadow bands again. All right. Cool stuff to look for, right? All right. Here's what to expect in the rest of Illinois. So we've got, excuse me, I need to cough for a second. So I'm going to mute my microphone. There we go. So in Illinois, farther away from southern Illinois, less of the sun is covered by the moon. As you get towards southern Illinois, more of the sun is covered by the moon at its maximum, until you get down into this area, which I've been calling the path of totality. That's where the moon's dark inner shadow is going to sweep over you. The rest of us are going to get the lighter outer shadow. And so we're going to see, excuse me, we're going to see a partial solar eclipse only. We're not going to see the moon fully cover the sun. But if you get down into that path of totality, you will be able to see, if it's clear out on April 8th, you'll be able to see the moon fully cover the sun. Up in the Rockford area, maybe 93, 92% coverage, on down to eventually 100%. All right. Now, I'm going to stop sharing and switch and go over to a website, because this is actually much easier for me to show on an actual website. So I'm going to share my screen on a website. It's going to go to this one right here, and I'll wait for it to load. Okay, this is a website that if you want to write down this web address, and I'll do my best to remember to put it in the chat as well so you have it, timeanddate.com, timeanddate.com. You want to write out all the words, timeanddate.com. And I want you to go to the Sun, Moon, and Space drop-down menu and scroll down, April 2024 total solar eclipse. Click. All right. So first off, there is general information. However, the neat thing about this site is it will detect where it thinks your computer is. So it should be at your town or some relatively nearby town. So I'm in Aurora. So this eclipse is visible in Aurora. Go to local timings and animation. Click, although it will say your town. It will say this eclipse is visible in Elgin. This eclipse is visible wherever you are, Bartlett or what have you. So it will give you the exact timing for your location. So in Aurora, we're going to get just under 94% coverage. And here's the timing, just a tiny bit off from what I showed you, those timings. They were very general for the Chicago area. Again, you can scroll down, and there's an animation here that'll show you what to expect. Now you know where I got my screenshots from, right? Here are the other timings as well. But what is also here is a map. And I'm actually going to search for a city. So up here in the upper right, I'm going to put Elgin, Illinois, because there are several Elgins, and city of Elgin, Illinois. Make sure you get the right location, because there may be several regions with the same name. So first thing it's going to show you is the lunar eclipse info. All right, scroll down, April 8th, 2024. We're looking for Elgin. Here we go. So here are all the particulars for Elgin. It looks like about 93% coverage in Elgin. Here's what to expect. Here's all the timing. But you can also click on this map, and it'll bring up a new page, and it will put a pin where Elgin, Illinois is, and it will show you the timings there, but you can scroll inward. There we go. And depending on where you're going to be, you can get pretty darn specific. And this is going relatively slow because I'm doing Zoom and the internet at the same time. But you can get really specific with where this is. You can pretty much go to the block where you're going to be. So you can use this for whatever site you're going for. But you can put in a city and, oh, wait, I'm really not going to be there. I'm going to be here. You can click on the map and it'll show you the particulars for that eclipse. Oh, I'm going to be in Decatur. It'll show you Decatur's specifics. Up here, I'll go outward. It'll show you, oh, maybe I'll be in Macedonia, Illinois. Oh, Macedonia gets to see totality. So there you go. This is an extremely, extremely helpful website. Keep checking it, or check it just prior to going to see the eclipse, just because some of the timings might change just a tiny bit. The more we get, the more precise we get with the moon's orbit and the calculations from all from the spacecraft that we have that study the moon. All of that goes into getting more and more precise eclipse timings. So if you want to get as precise as possible, check maybe a few days prior to the eclipse. There might be a new estimate at that point. So pays to check. All right, so I hope you find that site useful. I definitely do. I'm on this site at least a few times a week. All right, so let me go back to my PowerPoint here. Okay, so I had some screenshots just in case I was somewhere where I couldn't get an internet connection. So, but again, there's other parts of the country that you can look at the entire planet if you want to, and click around and see what the eclipse timing is going to be. Please notice, say Columbus, Ohio. See this part of Columbus right here that is not in the path of totality? This part of Columbus right here will not see the corona. So if you have a place in mind where if someone says, oh, I live in Columbus, close enough, we'll just go there. No, it depends on exactly where you are. Places that are outside the path of totality will not see totality. It's not close enough. There is a difference between 99% coverage and 100% coverage. So this is definitely something you want to go those last few miles into the path of totality to be able to see this eclipse fully. All right, those of you going to totality, what are you going to be able to see in the sky? Well, there are some planets that will be visible in the sky. Whether or not you see them depends on two very important things. I'll get to those in a second. But we have Jupiter, they'll be visible up and to the left of the sun and the moon. Mercury might not be visible, probably a little bit dim for that, but you know, you can try. Venus, definitely visible. Venus is definitely going to be bright. And then over here, Saturn and Mars. So there actually will be a comet in the sky at the same time. Whether or not you see it is really hit or miss. It depends on how bright the comet gets. Would not be surprised if we don't see it. But there will be one there, no matter what. Whether or not we see it is another thing. But there is a comet that will be visible in that same region. It will be a little bit to the right of Jupiter. Those of you going to totality, I'm here to tell you something you can do to help up your odds of seeing maybe some of the dimmer planets, or maybe seeing some detail in the corona. The maximum amount of totality is only about 4 minutes. That's not enough time for your eyes to fully adjust to the dark. So how can you help with that? You've only got 4 minutes. We can't change that. Please consider taking an eye patch with you. Just go to a party store or something, get a cheap pirate's eye patch and put it over one eye. And maybe put it on your eye about half hour, 40 minutes prior to totality. And then as soon as totality hits, so you've got that eye in the dark the whole time. Keep your eyes open, both of them open, just one of them is covered. And that eye is adjusting to the darkness for that whole time. And as soon as totality hits, you switch that eye patch over to the eye that had been in the light. And now this eye is fully adjusted to the dark, and you have a better chance of seeing a lot more detail in the sky. Now, here is the historical precedent for this. You think, oh, that's going to look really weird. Well, yeah, so what? This is your one chance to see totality in person in driving distance. So consider doing this. There is historical precedence for doing this eye patch thing. Have you ever seen a picture of a pirate? I bet you have. Probably thought pirates lost a lot of eyes in battle, didn't they? Is that why they wore the eye patches? And the answer is no, that's not why they wore eye patches. Pirates wore eye patches because if they were attacking an enemy ship, they probably would need to go down below deck. And if they were going down below deck, they were going to a part of the ship that would be dark. So they needed to have their eye adjusted to the dark. And when they would go down into the hold, they would switch the eye patch over to the eye that had been in the light. This one could now see down in the dark because you ever noticed you're walking around your darkened house and you can still see a few things if you've got a tiny bit of light? Well, the pirate did not want to be surprised by anyone coming after him in the darkened hold. So you would switch the eye patch over. And I guarantee there's some of you out there going, oh, we never were taught that as to why pirates wore eye patches. It was to adjust an eye to the dark. You can do the same thing for totality. If you're outside totality, don't worry about it. There's no reason to, but you can do this for totality. All right. There are other ways if you don't have solar glasses or solar viewers. There are other ways to see images of the crescent sun, the partially eclipsed sun. Grab anything in the house with a hole in it. So grab the pasta strainer with the holes in them. So holes in it. So here is a pasta strainer. Notice that this gentleman is not looking through the holes. This gentleman is using the holes as little projectors and projecting images down onto the ground. So each one of those holes becomes a little projector to project images of the partially eclipsed sun. You can just get an index card with a push pin in it and hold it just like this gentleman is doing. You're holding it off and hold it pointing that hole toward the sun and then projecting the image down onto the ground. The hole acts like a lens. You don't want to look through it. You'd be putting a focused image of the sun on your eye. Don't do that. This is just for projecting, indirectly viewing an image of the eclipse. All right. You can interlace your fingers. The spaces in between your fingers act like little pinhole projectors. And so this is showing you that right here. And you just want to hold them pointing toward the sun. And this works. I did this for the 2017 eclipse. It works for any of us looking for, if you've got the sun covered at about 50% or more, you can use this method pretty well. It works pretty well. Anything with a hole in it, and I guarantee you're all laughing at this slide right now. So this is a real picture, by the way. So the holes in the cracker, each one of those holes became a little tiny pinhole projector to create little tiny eclipsed images. This was from 2012. So this was an eclipse that was visible in Japan or somewhere in thereabouts. All right, the solar glasses or solar viewers. I'll come back to how we use them in just a second. I want to get through. Actually, I can stop sharing my screen. Let me just double check. Yes, so I'm going to stop sharing my screen so that you can see me. So the way that you use these, and I'll show you one more site, the site that I was going to show you up on the screen there. The way you use these, same thing for the glasses, either one. You want to hold them so that the shiny, the reflective, the silvery side faces toward the sun. And there is a dark colored side to this film right here. So there's a shinier silvery side and a dark side. The dark side faces toward your eyes, right? So silvery side toward the sun, dark side toward your eyes. You want to put it over your eyes, then look up at the sun, enjoy, then look down and then take it away, right? With the glasses, same thing. Put it over your eyes, look up the sun, enjoy, down and take it away, right? So don't just wander around everywhere with these things on because they are very, very dark. One of the very few things you will see through them is the sun. Everything else pretty much is not as bright as the sun. So you'll only see really, really, really bright flashlights through the solar glasses, or the solar viewers, either one. So don't just wander around with these on your face the whole time, because you want to be able to look around. There, it's dangerous to you might trip over something. So just be careful. Um, Also, uh, the glasses, the viewers, these were only designed for your face. Don't put them over telescopes. Don't put them over your DSLR camera. One exception, you can tear a piece of glasses, or your glasses, so you've got one lens, and then you can put this over the lenses of your cell phone. What I would like you to do is keep it all intact and just put this over all the lenses. Make sure no lens sees any part of the sun directly. And you can take pictures. What you can do is turn the video setting of your phone on, and you'll want to like prop yourself up against something. You want to keep your hands from shaking. So prop up against a tree, or put your hands maybe on a fence or something like that. Just make sure you got everything nice and steady. So turn on the video setting on your camera and turn on the setting called HDR, high dynamic range. If you've got these things covering the lenses on your phone, you're going to have this bright orange circle and then darkness all around it. Your phone is going to think there's something wrong. And so it's going to try to keep focusing, unfocusing, and it'll just go haywire. So turn on high dynamic range. That way you're telling your camera that there's this bright area and this dark area, that there's a high range of brightnesses on that screen. All right. So high dynamic range, video setting, take a video for maybe 10 or 15 seconds. Stop it, take a look. Surely one of those frames will give you a nice image of the partial solar eclipse. If you're going to totality, you could take pictures of totality. You would have to take this off your phone. However, I'm here to tell you, if this is your first totality or even your second, don't waste your 4 minutes trying to take pictures. It is not worth it. There will be lots of professionals taking pictures. You can grab any of those pictures afterwards. Please consider not taking any pictures during totality, except possibly recording everybody's reactions around you. I want you looking up at totality. Don't miss that. All right. Like I said, 4 minutes is going to sound like an eternity, but in reality, it's going to go by in a snap. All right. Very last thing is, if you need to purchase solar glasses anywhere, I'm going to show you where you can get information about safe glasses, safe solar viewers. And I need to go to this website here. There we go. And I'll give it a second. All right. So this is the website of the American Astronomical Society, Eclipse. .aas.org, eclipse.aas.org. And you want to go to the eye safety section, and I just moused over it. Scroll down, suppliers of safe solar viewers. Click. On the page that comes up, scroll. Here is the list of non-counterfeit solar glasses, all right? These are all links. Use these links specifically to go to the stores that will sell these specific uh, manufacturers and vendors, and they will sell the legit stuff. Assume everything else is counterfeit, because the counterfeit stuff has been on sale for about 2 years. And the giant third-party vendor sites do not police these for whether or not they're legit. They can't. It's too big of an operation. The counterfeiting operation is just too much. So assume everything is counterfeit unless it comes from one of these sites right here. If you happen to get one of these solar viewers, these are legit. If you get them from the library, those are legit. All right. But a lot of them just being sold anywhere, a lot of them are counterfeit, unfortunately. So just be careful. and get them from the reputable site. Okay, that is it. And I'm going to put, before I forget, I'm going to put those two websites in the chat. And let's see, I'll put the two sites in the chat. Give me just a second and I will grab those. I just need to get the text here. I will copy paste. So there is in the chat the AAS Eclipse website, and let me get the time and date site for the April 8th solar eclipse. So give me a second and I will grab that for you. There you go. So I think I saw someone say you can, the glasses are really helpful to be able to directly view the sun. However, please check your glasses and your solar viewers before you go out to use them with the sun. Make sure they don't have little rips, tears, pinholes, anything like that. Shine a really bright flashlight through them. And if you see light, except for maybe a little bit of light from the flashlight itself coming through, if you're seeing a bright little spot or a tear or a rip, throw them out. Do not take any chances with your eyesight. Okay. These things cost a few tens of cents to print. All right. Okay. And I'm checking, I'm checking to see where everybody's going. Okay, Carbondale. Yes, I will see you in Carbondale. That's where I'll be. Southern Illinois, awesome. South of St. Louis, fantastic. And Buffalo, I believe so. I think they'll be able to see it. You can check the time and date map to see the timing for that. So fingers crossed for you up there in the Northeast US. Going to Rochester. Oh, Bobby's going to Rochester. Hey, Bobby, if you're still on. The Science Museum in Rochester is throwing a big party. So if you're going there, say hi to my friend Dan. He's the guy in charge of the Rochester Science Museum's big eclipse events. So they should be throwing a big party. So definitely go check them out if you can. So we got someone going to Kaskaskia. That's great. Not sure where yet. Indiana, Missouri. Definitely, you can play it by ear. See which place maybe a day out has better weather. I know the hotels are probably all sold out, but if you're just driving down that day, you should be okay. So, all right, let me check the Q&A real quick. Okay. It seems for this upcoming eclipse, we wouldn't be too impressed. When is the next one you think will be worth adjusting schedules to see? This is the one that this is worth adjusting schedules to see, truly. So this one, while it's not totality, it is still more sun than you're going to see covered for literally decades. So the next time we see even remotely this much sun covered by the moon will be in 2029. And it won't be that much. It'll be like 60% or so. The next time we'll see a total solar eclipse in the United States is in the 2040s. So I would push back a little bit that, okay, this one for our area may not be totality, but it's still a lot of sun covered. You don't see this every day. All right, so I hope you might reconsider checking this one out. Where's the closest point on the path of totality from Elgin? It would probably be probably take an I-65 down toward Indianapolis. So going that way. So instead of maybe the 5 hours, 5-ish hours south to Southern Illinois, maybe 3 hours south or southeast to Indianapolis area or that general area of Indiana. So 3 hours, 5 hours. Again, kind of depends on the weather. So if you notice that Indy's going to be cloudy, but Southern Illinois is going to be clear, maybe go the extra hour or so south of south in order to see it. So give yourself the best chance. All right. Is it true that taking photos of the eclipse can damage your camera or cell phone's lens without a solar filter? Yes, yes, it is absolutely true. You don't normally point your camera at the sun. You wouldn't do it during a solar eclipse either, except if it's totality. But at that point, you're going to be fumbling with it the whole time. Don't do it. Just don't. It's safe, but you're just not going to get great pictures with your phone. So definitely you can cover your phone's lenses if you sacrifice one of your solar glasses and put a lens, put a lens of your solar glasses over the lenses, all the lenses of your camera. So give it a try. If I have solar glasses from 2017, are they still good to use? Yes, they are. So that material does not expire. So as long as you've kept it dry, safe from pinholes, rips, tears, folds, it's not just sitting in the junk drawer. If you maybe kept it in an envelope or something in a folder, yes, it should be okay. Check it, shine a really bright flashlight through it, make sure that you see no bright spots of light or obvious rips or tears or anything. But if you're checking it and it looks like it did when you put it in the envelope in 2017, you should be okay. Do eclipses happen on other planets? I love this question. I get this question a lot. And the answer is yes. Not every planet, though. Some of them, it's obvious why. They don't have moons like Mercury and Venus. So no eclipses there. Um, Eclipses on Mars are not total. The moons are not big enough to cover the sun completely, and they're not close enough to Mars to be able to cover the sun completely. So you could say it's a partial solar eclipse on Mars. And there are photographs taken by some of the Mars rovers of the moons passing over the sun. You can find those on the NASA website. We sometimes call those a transit rather than an eclipse. So you might see either word used. Jupiter is where you will see total solar eclipses because Jupiter's four largest moons, especially the ones closer in, like Io or Europa, um, they are large enough so that you can sometimes see shadows of those moons on the cloud tops of Jupiter. The orbit lines up just right with the sun as well. And if you see any of those pictures with this little dark shadow spot on Jupiter's cloud tops, if you were underneath that shadow spot, you would see a solar eclipse in Jupiter's atmosphere. There we go. Um, okay. Someone asked, does the library have glasses available now? They're going to check. So the availability will vary. It will depend on what they've got them uh, designated for. So that's why I definitely wanted to mention purchasing solar glasses and where to do it. If you're going to buy them, get them now because they will run out prior to the eclipse. So definitely best if you find a place where they make you buy like 20 of them, fine, go in with the neighbors, get an order going on your block, then everybody's covered. You can, it says, please call to check for the library, and the phone number is in the chat. Got some from American Science and Surplus in Geneva. I would tend to trust that American Science and Surplus would have legit stuff. So yeah, that's I've been there many times myself. So really great place. Um, oh yes, and someone mentioned that my name is very similar to Michelle Nichols, the lady who played Lieutenant Uhura on Star Trek. I was not named for her. My parents just needed an M name. So, but I don't mind being associated with her at all. She was cool. I wish I would have gotten to meet her. All right. Any last questions before we end for tonight? We are up against the top of the hour here. Let me check the Q&A. Is there any reason to take a telescope along? Yes, if you want to take a look for the partial phases of the eclipse, as long as you have a safe solar filter. I'm going to put another website into the chat. Hang on. Hang on. There is a site that I use a lot to be able to purchase. I'm waiting for it to load. To purchase solar viewers for telescopes and DSLR cameras. So it's called Thousand Oaks Optical. They're out of Thousand Oaks, California, and they're really great. And they use the same material that's in solar glasses in their solar filters for the cameras and telescopes. So if you don't have a solar filter for your telescope, you could. If you don't want to drag it along, then don't worry about it. If you want to maybe see the sunspots a little better, if there are any at that point, great. If you don't want to worry about it, one less thing to drag around with you, don't don't worry about taking it. Um, ah, I had an anonymous person say a very kind comment. Thank you. Did I go to Mexico with the Adler Planetarium for the total solar eclipse? If you're talking about the, I guess that would have been the solar eclipse in 1991, possibly. I was not at that one. I was at the Adler had a trip to the total solar eclipse or was it around 91? I think that's about when that one was. 1999, there was a cruise to the Black Sea, and that's where we saw that solar eclipse. So I was not in Mexico for that one. Some of my colleagues at the time, I've been at the Adler since 1995. So the folks who were working at Adler prior to when I got there, some of them got to go to that Mexico trip. So you didn't get to see me, but you got to see a few of my colleagues. So, oh, they were on that trip. That is fantastic. Oh, that's awesome. I believe that one was the 7.5 minute eclipse, I think, if I remember correctly. Maybe. Don't quote me on that. I think that one was. So, all right. They said, yes, yes, it was. Awesome. My brain remembers. Oh, another comment. You were there too. Oh my gosh. I can't even imagine how amazing it would be to see totality that long. And I bet it still seemed like it flew by in a flash. I just remember the 1999 eclipse. That one was about 2 minutes in length. And I was given the best advice ever. And it was just, Michelle, just look at it. Just look at it. Don't look away. Just look at it. So I couldn't tell you if there was other stuff visible in the sky. I didn't tell you if my shadow was sharp or anything like that. I didn't care. I was looking at totality, burning it into my brain. That's the best advice I can give anyone. So anyway, um, someone asking if I do programs for Adler on a regular basis. Yes, it's not on a regular basis, but I do a series of programs that we call Sky Observers Hangout. And it's my staff member Hunter and I, and we talk all about stuff to look at in the sky. And it's on YouTube, and it's free. You just join the Adler's YouTube channel and you can watch it. Actually, you don't even have to subscribe to the channel. It's youtube.com/Adler Planetarium. Our next program is tentatively scheduled for February, provided the weather isn't as cold as it was in January, the night we were gonna do it, and it was like 15 below. We didn't do it that night. So fingers crossed the weather's good, but we have it scheduled in February. So you can go youtube.com/Adler Planetarium, search Sky Observers Hangout, and you will find us. We're also going to do one the night before the solar eclipse from Carbondale. So those of you in Carbondale, if you're on the campus of Southern Illinois University the night before the eclipse, so April 7th, 7 p.m., we will do Sky Observers Hangout live from the campus. We're broadcast on YouTube. You can join us 7 p.m. Central Time. And we'd love to have the live audience there. Bring your lawn chairs, come watch. And it would be fabulous to have you all there. All right, I think that's everything. I don't see any more questions popping up on the screen.